Okay, guys, let's get started. Let's continue with the filtering work. Just share this with people here in Discord server. And turn on the live chat. Okay. Nice. So let's continue with the hashtag, the symbols filter. I'm gonna add a breakpoint here. Actually, we'll need to add the flush line here. So we need to add this and then flush, and same here. Oops. Okay, this now looks good. So go back to FilterPy and run. Let's see what type of data we capture with this hashtag logic we just added. We can incrementally improve this as we are iterating. But in this first iteration, we just want to set everything up. Okay. Okay, I think we need to first delete this and then it off again, so we're not mixing up results from different runs. Again, run. Hope you guys are doing well. And let's see the results now. So debug symbols. So you can see we are mostly capturing these problematic sentences. Most of them are like foreign stuff or whatnot. Let's keep on just watching at this data. I'm gonna put this on the right here and open up the filter.py and put the breakpoints somewhere here. Let's see the amount of sentences we processed, 250,000. We probably can reduce the number to even lower. Best open source LM to fine tune for robot actions. I don't know on top of my head. I would suggest you check out something like Saycan. Some of that work from Google might be insightful. So Aaron says he just finished his CS degree and is on his first data science job. I've been assigned to research on speech processing ML, mostly speech to text and text to speech. and basically figuring out the overall landscape. Any tips? Incrementally find a couple of papers you heard about, and then work your way from there. Just see what it references, some previous work it references, and then try and kind of trace back, create a certain graph of various papers, and then start skimming the abstracts and the images. Maybe check out some blogs, like it's just, and then start reading the actual papers. Hopefully that helps. I mean, it's a very high level answer. Okay, so we have currently number let me just see, what did we set for the as the default value for number of hashtags? Okay, 3. So if it's bigger or equal than 3, we flag that. Yeah, this is definitely super bad content, so it's good we are filtering it out. Okay. While this is running, let's check out some papers on machine translation and see how people have been dealing with data processing. Filter out dates for mine data. Remove the punctuation from both ends of the sentence. Okay, let's see what we have here. Yeah, a conceptual map is a good name for what I described. Thanks a lot, man. By the way, check out the Open NLLB channel in my Discord server. That's the best way to see what we are up to with this project. And also you can follow me on LinkedIn if you're curious about. I mean, I post a lot of relevant content about machine learning in general. Okay, let's see filtering. Let me just go all the way here. Is there any section on data? I guess that's this. Training a tokenizer. Primary, mind. Filtering strategy. Okay, I think this is the relevant section. Let's quickly skim this filtering strategy section, and then we can also check out some other papers. Okay, so they do link some papers here. Let's see what this is. Filtering. Okay, we might find something interesting in this paper. I'm gonna put it next to this one. Let's wrap up the reading here, and then we can continue to that one. Let's just find some inspiration here. Okay, I guess we can always rerun the laser model if we want to have more stringent constraints and filter out more aggressively. LID filtering. With thresholds chosen appropriately based on the reliability of LID scores for each of the languages. Let's see quickly section 5.1. Is there any mention of the scores here? Okay, this is more for monolingual data, I think. Yeah, I don't know any content creators who are like focused on a particular field like speech processing, honestly. Sounds good. Okay. Toxicity filter. Okay, I think we can reuse the exact deduplication normalization. There is no extension that's supported by Chrome by default. No worries. So section 7, effects of filtering. Okay, this is just for toxicity filtering. Let's quickly skim through the diagrams at least. Okay, let's go back to 94. Okay, let's go to some other paper. This one. And then we can check out, I guess, many of the large language model dataset preparation papers or sections are informative and relevant to us as well. So that's good. Filtering noisy parallel corpora. Impact of noise. Findings. Okay, let's kind of skim through this. Okay, nothing relevant in this section. Impact of noise. Findings of previous shared tasks. Monolingual pre-training. Filtering. Okay, nothing relevant here, really. Lunch was great, and I also grabbed a power nap because I didn't sleep really well last night, so like perfect. I'm fresh, slowly getting back to the wakeful state. Okay, no special instructions in this paper. Length of sentences in terms of tokens or characters, ratios, ratio of alphanumerical tokens, language ID, laser, Okay, nothing interesting here, honestly. We can just ignore this paper. Let me see, what else? I had maybe a couple of brief exchanges with him, nothing special, honestly. He's fairly focused on his own work and not that... I don't remember he was very, like, into socialization with others. Other than his very narrow team. Okay. Which papers might be relevant for us here? Let's see the original paper. Let me open up this one. See whether they had any mention on the filtering. Nope, no mention of the data. What could be something that's relevant to us here? Sounds good, man. You have a nice rest and then catch you later. Refine web paper. File paper. Again. Nordic file paper. What else could we read? Maybe there's something interesting in these ones. And then there are also a couple of papers in Serbian, so let's open up the literature page and find the papers. Let's see whether this one makes sense. Can't I just a second? couple more, and then these ones were made in Serbian, I think. Let's see what I say. I'm just gonna open it up. Okay, let's find some more inspiration here. Let me quickly see what's going on with our filtering. Let that run. Opus. They were filtered to remove the noisy parts. Disproportional sentence length. Sentiments with more than 1/3 of non-alphanumeric characters. Classic. Let's see this one. Is filtering mentioned in this paper? It's not. Structural filtering. Okay, nothing insightful here. Sampling and filtering of neural machine translation distillation data. Comparison of data filtering methods. This should have relevant information. Okay, let's see what they use for filtering. To score each sentence pair, they used laser. Nah, not really useful. I remember this one had interesting processing pipeline. Okay, here's the data processing pipeline. Yeah, this is gonna be interesting. And then results. So, section 4. We should probably parallelize additionally the computation we have. Because, yeah, we can... Our problem is basically embarrassingly parallel as well, because we just care about a single pair. So we can split however we want that across multiple threads. Non-printing character removal. Cache, I guess, for deduplication later on. Number of words, number of sentences. Do we currently do this non-printing character removal? I'm not sure whether we do this. Let's see. Where could we be doing that? Okay, we just write to the source. We apply a ton of filters. We do normalize. Unicode punctuation. We do this. That's correct. But they do non-printing character removal. We don't do that. Let's go back to filter.py and let's add gonna add it as a to-do. Let's continue to section 4.3, quality filtering. Okay, let's check out these two papers. I know about the Gopher paper. So both this one as well as Refined Web were both inspired by the Gopher paper. Let's see. Let's go back here to quality filtering. Most of these filters are inspired by Gopher and Roots. At least 80% of the words contain an alphabetic character. Okay, we might be able to add something like this as well. Go to the symbols. At least 80% of the words contain an alphabetic character. Ellipsis to word ratio less than 0.1. Flagged words. Oops. Each flagged word is coupled with a weight in the range 0 to 1, where higher weights are worse. The document contains less than 4 flagged words and less than 3 unique flagged words. Hashtag to word ratio is less than 0.1. Okay, we used kind of absolute number of hashtags. Mean line length. Mean word length. Mean of the median value and mean value. This is confusing. Let me just parse it again. So let the mean mat be the operation of computing the mean of the median value and mean value. What? Mean of the median value and mean value. What? Why would you want to do that? Number of characters. Okay. It's probably more relevant for large language models than for what we need. Repetitive gopher. Okay, this is less relevant to us because we have smaller sentences up to 1050 characters. Okay. Fuzzy dedupe. Let's read this section and then I think we're done. Yes. There is a bit more interesting stuff going on in the appendix when it comes to fuzzy dedupe. Let's quickly skim through this because this is also relevant to us. Okay, we'll probably have to create a separate stage for fuzzy dedupe, as we previously concluded, because we have to create these clusters, connected components, better said. Okay.
Epa, može. Live stream. Sad, ali...
Let's see, what's this section? Intra-shard deduplication. These types of shards is hence suboptimal.
Eu vou extrair de serviço.
Okay, merging of duplicate groups. This is the relevant part. Combines the duplicate groups by identifying connected components. The naive approach would be to keep one document from each of the found groups. Since we have deduplicated all shard pairs, each duplicate group may only contain documents from at most 2 shards. Okay, we read this before as well. Just trying to refresh my memory. Okay. Let's see what parameters did they use. B smaller bands. We used 2 bands, okay. Threshold of 0.5. Okay, they didn't mention the R, the size of the subvector. 2 bands, threshold of 0.5. Can you actually infer R if we have the threshold and the band number of bands? Did they release any of the code? Nope. Okay, again, let's just skim through this one quickly. We went through it multiple times already. Reading the data, URL filtering, text extraction, language ID, line-wise corrections. Let's see what these two are. Okay, I don't see anything special here that we didn't already see. Let's search for symbols. Okay, guys, I think we are good for the initial filtering iteration. I don't want to overdo it. Let's maybe just see what the roots did here. Data, data, cleaning data, processing for quality improvement. Filtering. Okay. Data cleaning and filtering. Too high character repetition or word repetition. Too high ratio of special characters. Okay, we're good. I think it's better to use, instead of absolute number of hashtags, this sentence is completely valid. We filtered it out because we have found a couple of hashtags here. So I don't know. I think it's fine for now to just have hashtag number be absolute. If you have more than 3, maybe strictly more than 3, or okay, let's now think how to devise some heuristics. I want to also capture the notion of a ratio, not just absolute. Let's somehow combine those two together. So we need to see how many words we've got. Why is it taking so long to process here? What's going on? Okay, I'm gonna check whether we have some bugs later. But for now, let me stop this. And let's go and improve the symbols filter. I'm gonna do this later. I first want to focus on the punctuation and the symbols. Okay. And then, okay, let's just start with the symbols. Let's implement the 3 to-dos I have left. Let's close those. So digit to character ratio less than 0.2. Okay, so let's compute the number of characters. And how can we do that? I did develop this Cyrillic logic. Let me just find inside of FairSec. I built some of these scripts that have to deal with Cyrillic and Latin scripts. Script utils, here it is. And as a part of this, we have this process line function. That does what? It removes the punctuation or non-printing characters, removes all of the white spaces, removes all of the dashes, underscores, punctuation, and digits. This one combines Unicode punctuation replacement with non-printing characters replacement. So non-printing characters are these ones, Unicode, and we end up with this. Whoops. Find the keys. If we find any one of these or any one of these, we just remove them, and then we remove the white spaces. So we do need this. Okay, let's just grab this function. Can we reuse? Okay, I'm gonna just copy paste this for now. Digit to character ratio less than 0.2. Fair enough. At least 80% of words contain alphabetic character. But that's kind of arbitrary. I want to implement this one. So how should we call this one? We basically remove everything. We don't want to remove the digits. Just put that here and comment it out. So we remove these characters, we remove the white spaces, dashes, underscores, punctuation, and we are left with characters and with digits. And then return character to digit ratio, something like that. So now let's just compute how can we count the number of digits? Okay, fair enough. And count the number of characters. Okay, is alpha, nice. And so now we retrieve back the ratio, which is going to be and this one should be smaller than 0.2. So if you're bigger than 0.2, no, this is actually returning digit, wait. Digit to star ratio. If that's over 0.2, like this. If that's bigger, in that case we remove the line. And we repeat the same thing for the target line. We're in the debug mode. Then we save that line, and we also increment the number of the symbols variable, and then return none, which means we filter out that line. Okay. Digit to character ratio less than 0.2. Sounds about right. What about making sure that alpha, at least 80% of the words have alphabetic character? Well, actually, we don't even need to do this then, right? This is unnecessary. We just need to compute digits to alpha ratio for the line. Let me quickly check Nordic file paper again. At least 80% of the words contain an alphabetic character. Let's add that one and see what it filters out. It's easy for us to do that. So let's do the following. Split the line on white space. No, this is not good. We can always do something like this. replace the white space with a space, and then words are this, and then we go through the words for word in words. Has alpha. If it has alpha, we increment. Otherwise, we don't. And then at the end, we just retrieve back the percentage. So we say counter over length of the words. Whereas has alpha, it's just going to be like this, and then if is alpha, then true, otherwise return false. Looking good. So again, we go through the words. If it has alpha, then we increment the counter, and then we retrieve back this. So this gives us the number of words that have at least one alpha character. Something like that. And again, hello Arush. So ratio of words with alpha ratio should be 0.8. I mean, I'm gonna experiment with that number, but you get the point. Looking good. And then time to implement this for source and for target. We could have, okay, we could have easily, we could have made this a for loop, but okay. So if ratio of words with alpha is smaller than this, in that case we filter it out, right? If it's too small of a ratio, we filter it out. And same here. And finally, we have one more to do. Ellipsis to word ratio. How do we detect ellipsis? Do we just use a regex? Or what? I didn't notice we have a lot of ellipses, but let's see. How do we count ellipses? If we have something like this, is this like 1, 2, or we do sliding window? Let me see what the mighty GPT-4 says here. Okay, let's just detect 3 or more dots and see how many of such patterns we have. If there are 3 or more dots, I want to save that file. Okay, let's write a regex that captures 3 or more dots. We have a match. Okay, search. That's all I wanted. Let's just see how many times we get something like this. Okay. This is more for debugging purposes. I'm just curious to see how many sentences satisfy that property. Okay, looking good. Stop the run. And let's see. Let's go one by one. Let's just comment out everything other than this is incorrect. Digit to character ratio. Okay, we can refactor this later. Let's just see which lines satisfy this property. Comment this out. This one as well. The digit to character ratio. If it's bigger than this, too many digits, in that case we save that sentence. Currently set to 0.2. Let's see how many sentences satisfy this property. Run. And we can now follow here. Oh, this is weird. That's not that many digits. Or maybe it is. That might be too small. We'll probably have to set that a bit higher. So if there is like 30% or 35% or more. Let's see what happens now. Run again. Let's see what we capture. Everything that has over 30% of digits, we're gonna capture that one. Okay, in shorter sentences, we might be capturing legit sentences when they're short. So we maybe can do some additional conditional statement. All of these look legit. So let's increase this. Let me see. We can do something like piecewise logic. But before we do that, let's increase this to 0.4. See what we capture then. Run. Okay, I'm not sure this is going to be super useful. And we should also be saving both the source and the target so we can see whether the translation is okay or not. So let's go back here. And let's just do source followed by why is this complaining? Because I forgot to add. Wait. Okay. This looks good. Let's do the same thing for all of the above. Here as well. Here as well. Here as well. And finally here as well. Kick it off again. Let's see what we capture. Can only concatenate string. What? Aha. Okay, that was a stupid mistake. Rerun. Okay, I didn't get to update all of them. So grab this one and update all of them. Okay, that should now work. Let's see where we captured some outliers, bad pairs. Again, go to filter, run. Okay, here we are. Yeah, all these are fairly legit translations. Okay, let me stop this. For the mine data, when we have numbers or dates, that's going to be usually incorrect. So we can filter those out, but that's a separate task we have. Let's try now and see how this works. The alpha filter. So if the ratio of words with alpha is too small, so I'm expecting to get a lot of emojis here, right? A lot of what this is supposed to capture is all the sentences where we have overwhelming amount of words with non-alphanumeric characters. That's the expectation. So let's kick it off. Okay, something is incorrect here. What's wrong with the logic? Let's rerun this just to see whether this makes sense. Why is this not? Aha. Because we have hashtag 20. Okay, again, problem with short sentences. This makes much more sense for longer documents. Let's try it again. Let's just grab the outliers. Nah, something is not alright here. Why is this? Why is this captured? Am I getting something incorrect here? Let's rerun. Why is this smaller? Ratio of words with alpha is 0.9. Aha! Okay, we actually want to go to something like 0.5. My bad there. So stop this and then rerun. Okay, this is capturing bad translations. Definitely looks like a lot of those are bad translations. I feel we are mostly capturing mined sentences. And now let's manipulate this so that we enable the detection of ellipses. The hashtag definitely seems to be the best one so far. Let's capture this one. Comment out that one. And clean this file. Run the filtering again. Let's see what we capture. Okay, let's be a bit more strict. Go to symbols and capture only those that have 6 or more. Okay. These are actually legit translations, so I doubt this filter will help us. Okay, hashtag was the most powerful one by far. Let's also remove the quotation marks at the ends of the sentences. So I'm going to stop this now. Go back to fairsec. Find the data. And go to HBS data. Let's open up this one. I did notice that some sentences have quotation mark on like right hand side, but not on the left hand side. Let's capture those cases. Go to symbols. Quotation marks. Oops. So we want to capture these ones. Okay, let's call the Unicode. Let's map these Unicode characters to these ones and then find quotation marks disbalance in both in either target or source and then clean that. Let me see. Digit to character ratio. You probably need to have something like this. I'm not sure how his alpha is gonna work. What does his alpha capture? Alphabet letters only. Okay, this is good. Oops. Go back here. And then ratio of words with alpha. Fair enough. Again, might be worth... Nah, this is actually fine as well. For ellipsis, we need to first map before we do this. So we have to do something like this first. Not quite, but almost. We don't want to subtract with 0 with empty string. We want to map these ones to these ones. Okay, replace Unicode punctuation. Something like this. This on the line, and only then call this to get results. Okay, I'm gonna clean this a bit later. Currently just rapidly prototyping stuff. What else? Just a second, guys, let me turn on the lights. Okay, so where were we? Trying to capture the quotation marks. Not really. What I want to do is, this is okay, and then at the end of the sentences, if it starts with this one, so if it starts with this, this, or wait, what I'm trying to do here is get the disbalance. If there is any, if only the right one has the quotation mark, or only the left hand side has the quotation mark. Starts and ends with this, then it's fine. If it starts with this and does not end with this, in that case line should be modified maybe something like this. Okay, so what I've done is if it starts with a quotation mark and does not end with quotation mark, remove the first quotation mark. Okay. This modifies and filters the lines. Let me comment out all of this. I'm just gonna raise a flag if this happens. And just return back the flag. If this returns true, exactly, same here. Okay, so let's capture those disbalances. Let's see how often this happens. So if there's a disbalance, we write and flush. Okay. Let's go. Let's see how often this happens. Okay, here you can see there is a ton of these weird situations where it starts with quotation mark but does not end. And same here. So yeah, there is a lot of these. That's why I wanted to do this filtering. Okay, that was actually a good that was good work. I'm not sure what I meant by this is also valid for other languages. Okay. And finally, we have a couple more things. So one is to wrap up the fuzzy. And then there is also the filtering of the dates and number sentences from mine dataset. So if you're coming from mine data and you have a date in your sentence, we need to filter out those sentences. How can we do that? How do we know what's the source? Let's go back to filter. We have the dataset here, corpus name. We can label datasets easily, whether they're mined or not. If they're mined, we can add additional filter or something. Yeah, so if it's a mined dataset, we need to add additional filter. I'll have to do some serious refactoring after this prototyping phase, but okay. So if it's mined, we want to set some flag, and then when we are doing the filtering here, we want to do additional filtering of the dates. So maybe just append to the filters. Maybe like create extra filters. Or let me think. The symbols should be able to do this, right? To detect the dates and numbers. Yeah, let's maybe just create a separate one. So I'm gonna copy the symbols. I'm gonna call this, let me see. Just call it mine, whatever. And we want to do the following. We want to remove the dates. So we need to create various regex expressions. Force it to create a list. We need multiple of these because there are different ways of capturing the date. Why do all of these look the same? Okay, this is incorrect. Let's maybe use ChatGPT here. Whoops. Okay. So year, month, day, and then month, day, year. This is like the most retarded format ever. European format, day, month, year, year, month, day, and then this weird one, and then day, month, year, month, day, year. Okay, so if we find any one of these, this finds all of the matches. We just need a single match. Let's just grab the patterns. Okay. So again, this is year, month, day, and then month, day, year. These two are the same, right? And then day, followed by month, followed by year, month, followed by... Okay. This is a good start. If we find the date in either the source or the target, we filter them out. Okay. That's it. We'll test this after in the third and last stream. I think this is good enough for this one. We have to do some refactoring, do the fuzzy, and then we can kick off the final filtering job, and then we are close to kicking off our first ever run for Croatian, Serbian, and Bosnian data. Okay, guys, catch you a bit later. I'm gonna go grab some rest, and then see you a bit later in the last stream of the day. Bye, guys. Cheers.